Hi, good evening. Can you hear me? Can you hear me?
Yes, yes.
Okay, thank you. So just we're waiting some time, then we'll start, okay, for joining all of the participants. Okay, so let's go. We'll start today's session. So let me share my screen. Okay, can you see my screen? Is it visible? Okay, thank you. So let's go start. So basically today is our 6 number test, and today I discuss about that machine learning in Google Earth Engine and how to make land use land cover classification using machine learning, basically both supervised and unsupervised. So both of machine learning model, how we can easily apply, we also discuss about that. And random forest, then cart, support vector machine, minimum distance, and all of classifier, how to use, we also discuss about that. And finally, how to check the accuracy assessment of the land use land cover map. Suppose kappa accuracy, producer accuracy, consumer accuracy. So this type of accuracy, how we can check, we also discuss. And how to calculate the land use land cover classes area. How much build up, how much vegetation, how much barren land. This type of things also try to discuss. And how to add the legend, okay, on the land use land cover map. And how to export land use land cover map. We also discuss about that. Okay, so basically today focus only for the machine learning method, supervised and unsupervised. I try to explain all of those beginners to advanced level. And if you have no knowledge about the machine learning, and don't worry about that, I will try to explain all of term for the machine learning. Then I hope you can easily learn this type of things. So okay, let me open a code editor. Try to explain all of those step by step. I hope you can easily learn all of those. So first of all, what is machine learning? Okay, so basically, machine learning is a branch of artificial intelligence that focus on developing model and algorithm that let computers learn from a data without being explicitly programmed for every task. So if you check this website, so basically this website explain all of those more briefly, all of those, how it will work, what is the supervised learning, what is the unsupervised learning, what is the reinforcement. So everything we can get the more clear idea. For the machine learning principle pipeline, we also learn about that. All of those we can easily get. Mainly machine learning workflow, data cleaning, data processing in Python, feature scaling, feature extraction, feature engineering, feature selection. So this type of basic things of machine learning model, when we apply, not only for this sector, we can apply the machine learning different sector. Okay, different types of data set, we can use this type of machine learning model. Okay, so you can see different types of things we can easily use. So this machine learning we can also use for the classification. Suppose if you check, it's one kind of classification. Suppose have some label data, and now I have some label. Suppose from this data set I have some label. So in the label, suppose I have the cow, elephant, and camel. So this is my label data, and this is my label data, and this is my label, different types of label. So further, we simply apply a algorithm. This algorithm, it can be supervised, it can be unsupervised. So suppose supervised learning, we simply apply. So further, it processing the algorithm and output final classification. You find out suppose elephant, camel, or cow. So same like as for land use land cover classification also. Suppose I have some label data. It can be vegetation. It can be pearland, forest, then water body. So different types of label data, and I also have the label. So further, I simply apply the algorithm, suppose supervised algorithm, and further we simply set the processing and set that this is the water body, this is the forest, this is the cropland. So it's simply classified and show you the output of this result. So this type of things, how we can easily apply, we discuss about that. And if you want to learn more details how to apply the machine learning, all of theoretical part you can easily get from this website. So I also send you the link in our Google Classroom. You also check it, all of details, mainly how it will be worked. Okay, all of function, all of things we can easily get from here. So first of all, machine learning. So it can be two types, mainly three types. We can use the two type most of the time. We use the two types of machine learning. So first type, it's called the supervised learning. Okay, supervised learning. So supervised learning, it's one kind of type. So in supervised learning, we need the level data. Okay, level data. Okay, this is the common characteristics. So when we apply the supervised learning, we need the level data. So now what is the level? So if you check in this example, they are already set some example. So in this example, you can see it's a level data. Okay, level data mainly I already know. Suppose this is the elephant, this is the cow, this is the camel. So this type of data as a level data. So this level data, further I simply apply the algorithm and further just make the processing and then simply make the classification. So this level data you must need when we apply the supervised learning method. Okay, so any kinds of classification you can use, but when you apply the supervised learning, you must need the level data. Okay, level data, or it also called the pre-categorized data. Okay, pre-categorized data. Pre-categorized, mainly we can see what we already make the category. So this is the one category, cow. This is the another category. This is the another category for camel. So it's called the pre-categorized data. You must need when you apply the supervised learning method. You need the level data or pre-categorized data. Okay, but unsupervised learning, don't need any kinds of level data or pre-categorized data. You don't need for the unsupervised learning. So now, what is the unsupervised learning? If you check from here, for unsupervised learning, is the unsupervised learning. So there are three main categories: clustering, association rule mining, then dimensionality reduction. So basically clustering, it's very popular. We simply use it remote sensing to identify land use land cover classification. Also clustering we also use. So in the clustering, you can see we simply input our data. Okay, we simply input our data. In this time, you can see there is no label data. There is no label data. There is no pre-categorized data. So in this time, we simply input our data. This is our raw data. there is no label data. Simply apply our model algorithm, an unknown output, and no training data set. There is no training data set. So further it make the processing and make the classification. Okay, suppose all of elephant, just make the one category, all of camel make the another category, all of cow make the another category. So in this case, if you check, there is no label data. There is no label data. We simply apply our model on our data, so it automatically create the group. It automatically create the group. Suppose in this time you can see, create the one group for elephant, create the another group for the camel, create the another group for the cow. So for the similarity, it mainly identify for similarity. Suppose similar pixel for water, similar pixel for vegetation, similar pixel for barrenland, and make the classification. So you can also read all of those, then you can get the more better idea. So what is the clustering, and mainly we use the k-means clustering, okay, for the classification. So all of those you can get the more briefly. And if you just click on this type of link, suppose I click on the k-means clustering, then I can get all of information about the k-means clustering, how it will be work. Okay, you can see all of those you can easily get. Further, you also try to read this type of things to get the more better theory knowledge. In this time, we simply apply supervised and unsupervised. So of this lecture, supervised learning, you must need the label data or pre-categorized data. But unsupervised learning, you don't need any label data or pre-categorized data. Okay. So both of learning, supervised, unsupervised, both of learning is very helpful for the different purpose. For land use, land cover. Sometime we want to make the classification, but we don't have the ground truth data, or we don't have the training data. Then we simply apply the unsupervised learning, and then we can easily make the classification. Okay. So in this case, this suppose first of all, this is about the supervised learning. Then we talk about the unsupervised learning for the classification. So now what I classified. Okay. So in this time, we classified our image. It's mainly a satellite image. Satellite image. Okay. So in the satellite image, it can be Landsat, or Sentinel 2 or Sentinel 1, whatever, same process. Or it can be some drone imagery also, same process. Okay, so you can see in this time, I want to classify image, satellite image. Okay, and this satellite image, it can be Landsat, it can be Sentinel-2 or drone imagery or any other imagery, whatever. All of are the same process. So every image, every satellite image have some feature. So what is the feature? Feature, if you check, we already know about the satellite image. Just I show you the one example. Just let me open the satellite image. Suppose I want to work with Sentinel. Just click on here. On the Sentinel. If you check, suppose Sentinel to multi-spectral instrument. And if you check, suppose I want to surface reflectance. So these are satellite imagery. If you check this type of bands, B1, B2, B3, B4, B5, B6, B7, B8, B8A, B9. So this type of bands called as the features. The features. Or it's also called the spectral signature values or spectral bands. So this type of things in this time, it work as a feature in our model. Okay. In our model, we simply use this type of features. So now this is our features. So further we'll also use it. So first of all, we need the satellite image, Landsat or Sentinel-2 or drone imagery. After that, we simply choose our training sample. Okay. So let's guys simply import this image collection. Very easy way. We'll learn about that. Okay, just I copy. and filtered this image collection for our specific boundary. We already know about this type of process, how to filter the image collection. Okay, so in this case, we simply import our boundary, which area you want to make the land use land cover classification. So simply choose your import your shapefile. So simply import this Dhaka city boundary and then give a variable name. I put the name suppose ry. Okay, so then give a variable name in here. Suppose I put the name is it's a image. Okay, so now this image collection is simply filter for this study area. So you already know a lot of time we already write this type of code for filtering and visualizing the image. Suppose filter bounds this function with ROI, then put here the filter metadata. We already know about this type of things. Cloud cover, I set less than 1. Then I put the time when I need the image filter date. Suppose 2025. I just check from 2025 December 31. I take all of images. So now if you check how many images you have, just print and call the image and use the size function. So now it's computing how many images we have. So if you check, why it show the 0 image. Sorry, this is a cloud pixel per sentence. Okay, so this is the property of cloud pixel per sentence. Cloud cover, it's only for Landsat. Okay, so cloud pixel per sentence, it's a property name. So we find out total 35 images for my study area. So between this time for the 1 year, whole 1 year, okay, 35 less than 1% cloud for my study area. So I want to use all of images and make a median composite. Just put the median. Or if you want, you can also use the single image. Or if you want, you can also use the seasonal image. So I already show you this type of process, how to filter seasonal image collection, how to filter single, how to take the single image. Okay. So in this case, I simply apply the median composite and click with my study area. So now I want to display this image. Map.layer and call the image. Okay. Layer. And now I want to focus on my given study area. So map.center object is ROI. I put the general 10 run the code. So now directly focus on my given study area and we find out this type of imagery. But this imagery, if you check, just click on here and click the any place. So it show the DN value. Okay, you can see it show the DN value, very high value. Okay, 1006, this type of value. It show the DN value. So this DN value we need to convert into reflectance value. So for that, there already gives some scale value. If you check scale value, just like copy the scale value, you convert DN value into reflectance value. Same, just after the median, apply the dot multiply function, multiply, and then apply the scale. So now it convert into reflectance value. If you now check again, after adding the scale value, then click on this map or image. So I can show the reflectance value 0.1 or something, 0.07. Reflectance we find out for that. Okay. So now it rescaling process. Okay. Digital number into reflectance value we can get. So now we simply set the visualization. So just click on here. I set suppose red, then green and blue. I keep 98%. Then apply. And further, I just import this visualization. Copy these things and paste after the object name. And I put the layer name, it's the image. So this is the process. We simply choose our image. Okay. So now I take the 1 year median composite image. But if you want, you can also use the seasonal image. For the different purpose, we need the seasonal image. Okay. As well as if you want, you can also take the only for the single date imagery. Okay. For any specific date, same process. So now this is my satellite imagery. So I want to apply supervised learning. First time I just show you that supervised learning. So for the supervised learning, you need some label data. So this is my satellite image. So from this satellite image, I need to choose some label data. And what is the label data? Label data is what I classified. What types of class I want to classify. So it's called the label data. Suppose in this case, I want to classify label data. Suppose I want to classify, suppose from this satellite imagery, I want to classify, suppose this type of classes. Suppose water body. I want to classify, suppose vegetation. I want to classify, suppose build up. I want to classify, suppose Berlin. Okay, you can also add different types of class. Okay, no problem. Suppose you can also add the forest. If you have any forest area, you can also add the forest. Or if you have any agricultural land, you can also add the agricultural land. Whatever you need, you can easily add this type of things. So in this case, I just add, suppose I want to classify from this imagery, I want to classify water body, I want to classify build up, I want to classify vegetation, I want to classify barren land. So this type of classes I want to classify from this satellite images help of machine learning model. So I simply write this type of level. So I can add any kinds of level. Okay, what types of class you want to classify, simply write this type of name. So now after creating this type of classification I want to classify, so we need to take the training sample. Okay, so for this type of classes we need to take the training samples. So for the water, I need the training sample. For the vegetation, I need to take the training sample. For the build up, I need the training sample. For the barrel, I need the training sample. So now how I can collect the training sample from this satellite imagery? So we simply use the satellite imagery and take the training sample. Okay. So now how I can take the training sample? So for taking the training sample, so for this we need to use the band combination. Okay, for visualization different classes. So in this case, if you check, in this case I simply apply the band color. It's called the red, green and blue, mainly these three band. If you check the three band, red, green and blue. Okay, this is the red band, this is the blue band, and this is the red, then green and blue. Okay, three band we make it, then we can get this type of visualization, and I can easily get the idea. So this type of green color indicating about the vegetation, as well as this type of color indicating about that build up or settlement, we can easily get the idea. As well as we also get this type of place have the barren land or others. So not only for that, we can also use the different types of band combination. Suppose I simply add the another one. It's called the near infrared, mainly B8. Then I put here suppose red and blue. I stress and keep 98%. So now it's create the another band combination. Just I apply. So now if you check, we can get this type of visualization. Okay. So when we apply this band combination, near infrared, red and blue, then water body, it become a black color or dark color. You can see this type of black color show as a water body. Okay. As well as also this type of red color indicating about the vegetation area. Okay. Indicating about the vegetation area. This type of red color. It's a vegetation area. As well as if you simply check this type of color, gray color, it's indicating about the barren land area. This type of gray color indicating about the barren land area. This type of barren land area. If you zoom more better, get the idea. So you can get this type of place is the barren land. You can see this type of color indicating about that. And this type of black color or dark color, it's a water body. And this type of red color, it's a vegetation. Okay. So we simply set this type of band combination and you can easily get the vegetation, water body, barren land. You can easily get the idea. Okay. Not only for that, you can also use the another one. Which one is short wave infrared one. Then put the near infrared and put the blue. The tracing I keep 98%. So now it's create the another band combination. Just I apply. So this band combination, it's mainly help you to visualize and also help you to collect the training sample for each classes. So now you can get this type of band combination. So now it show the vegetation. It show as a green color. Green color. It's a green color. You can see it's a vegetation. Water body. It show the black color. Okay, and you can see this type of color indicating about the barren land. Okay, barren land. We find out that barren land. And also get the vegetation as a green color, this type of things. So this type of band combination is simply apply in our satellite imagery and use the different types of visualization to help me collect the training sample for different classes. Okay, so now how I can collect the training sample? So for collecting the training sample, click on the marker. You can see the marker tab. This is the marker. Click on the marker. It shows the geometry. Just click on the edit layer properties and set. Suppose I did the example for water. Just I put the water. Import as feature collection. Property. I put the property name, suppose class. And value, I set the value 0. Okay. So I start from the 0. So 0 is the first level. I set the level 0 is for water. Then okay. So now we can see it show the water bold font. Then further I simply choose the training sample. Just click on my water body. I can easily get the idea. Water body show as a black color or dark color when I apply this type of band combination. So now I simply choose this type of place is the water. So I simply take the training sample. It's a water. It's a water. I take the training sample. And how many training sample I collect for each class? So first time we simply choose more than 30 or 50. After run our model, then check the accuracy, and then we also increasing or decreasing. But first time try to keep up to 30 or 50. Okay, for each classes. Okay, done. So then I take the training sample for suppose vegetation. Just I click the new layer again. You can see the new layer. Click, and then put here vegetation. Port as feature collection, and put the property is the class. Okay. So this property name always keep the same. Okay. Property name always keep the same, and then set the value for 1. So I set the label 1 is for vegetation. Okay. Then click on the okay. So now take the vegetation. If you check this type of color indicating about the vegetation, this type of green color is simply choose. Or if you want, you can also use another band combination. It's not a problem. So band combination is just visualize, okay, for the different types of classes. Suppose I apply near infrared, red and blue. I keep a stressing 98% and apply. So now vegetation it show as a red color. If you check vegetation, this type of vegetation show as a red color. You can check. We find out. So this type of red color indicating about the vegetation. So just I simply take this training sample from here, from this type of red color pixel. You check this type of. You can see. Okay. Then I take the training symbol for Berland. Just I click the new layer and take the another training sample for Berland. And then feature collection property. So I set the property suppose class and set the value for 2. So I set the 2. This is the label for Berland. Okay, then okay. So I simply find out the Berland. So if you check, so when I apply this type of band combination, it shows this type of color is indicating about the Berland. Or if you want, you can also use the another band combination to choose it. Suppose just I apply the short wave infrared 1 and near infrared and below I keep stressing at 98% same and then apply. So now if you can check, we can get this type of color. Okay, it's a Berland. Also this type of color is the Berland. Also you can see this type of color. When I apply this type of band combination, it shows this type of color is a Berland. So this type of color, okay, it's a Berland or gray color or brown color. So we find out the Berland. So we can simply take the training sample for the Berland. So just select the Berland and simply take this is a Berland area. This type of place also. We can see this type of place. And Berland, sometimes it can be two types. Some places the wetland also have, or wet Berland or dry Berland also find out. So this type of place indicating about that wet Berland. This type of color. But you can see this type of color, brighter, indicating about that dry Berland. I make the combine together all of Berland. If you choose this type of place, also have some Berland. You can see this type of place have also. Okay. And finally, take the training sample. Suppose for build up, click on the new layer. Build up. Feature collection. Set the property. I put the property name, suppose class, and set the value for 3. So 3 is for label, all of build up. Just stay okay. So now, suppose I put another band combination. So we can use the different types of band combination just only for visualization, only for better visualization. So I put suppose red and green and blue. and further apply. So let's create the another band combination. So now we can easily get the more better idea, or you can see this type of place is the mainly build up. We find out, okay, place is also build up. Yes. So I simply did the training sample for the build up. Just click on the build up. You can see it show the bold font. Further, you simply take the training sample for that. This type of place. You can also more zoom, collect more better. So if you check this type of place is the build up. So here all of place have the build up. You will check. So this type of place also build up. We take the training sample from here. All of class. Again, this type of place. Okay, so you take this type of place is the build up. Okay, build up. So this is the process. So first of all, you simply open your own satellite imagery for your specific area of interest. After that, simply take the training sample. Okay, so you can also take the more training sample for the different classes. When you work with a real project for the different types of classification, also add, no problem. So just I take this type of training sample in my satellite imagery. So after taking the training sample, we need to merge all of training sample together. Okay, so now need to merge all samples together. So for that, we simply take a variable, suppose samples, and I simply call all of samples. So if you check all of samples name, so first of all, water, it merge with vegetation, then it merge with pearland, then it merge with build up. Okay, so now all of training sample is simply merge. So now if you check how many training sample you have, so just call the samples and run the code. So let's print all of samples with their label. You check the console tab, it show the total 197 samples with their label. If you check the label, click on here and click on the features. So if you check the label, we can get the label is the 0. So 0 is for water. If you check others training sample, 2. So 2 is for what? 0, 1, 2 parallel. So you can see now it's a level. We set the level. Every training sample, we set the level. Same like as when you discuss in here, if you check, so we simply set the level. So suppose this is my satellite imagery. Okay. So this is my satellite imagery of Dhaka city boundary. So from this Dhaka city boundary, I simply set some level. Suppose I set the level for 0, then 1, then 2, then 3, then 4. 0 is for suppose water, 1 is for vegetation, 2 is for barren land, 3 is for barren land or others. So we simply use this type of concept. Suppose this is my satellite imagery in this case, and we simply set the label for from this satellite imagery, and we find out this type of label. Every class is simply set the level. So now this is my training sample. Okay, so this training sample only need for supervised learning, and unsupervised learning, when you apply, don't need this type of training sample. So after creating the training sample, we need to extract the feature engineering. So features. So now I simply collect the features. So in the satellite imagery, we find out the different types of bands. Okay. And this type of bands work as a features. So now how I can choose the features? So if you check the different types of band. So this is the band for aerosol. This is the band for blue, green, red. So in this case, suppose I keep only for the 10 meters. I also keep 20 meters. This type of band. Okay, and create the features. So for the band 2, band 3, band 4, band 5, band 6, band 7, band 8, band 8A, then band 11 and band 12. I just keep from here. So for that, just take a variable. Suppose take a variable bands and make all of bands which I want to apply as a features in my model. So I put the name band 2, band 3, band 4, band 5, band 6, band 7, band 8, band 8A, band 11, and band 12. Okay, so this type of bands I can use as a features in my model. But further, you also add the more other bands, which bands is not available in my satellite imagery. But we can also use this type of band and calculate different types of indices. Suppose NDVI, NDWI, NDBI. So different types of indices we can also compute using this type of bands. So this type of bands further you also add as the features. Okay, after some time I'll show you that how it works. So now this is the bands. I simply choose all of bands. So now what is my target? I want to create a data set. So I want to extract the band pixel value for every single point. Suppose for this point, I want to extract all of bands values. And it's also called the spectral signature value. So I want to extract all of band pixel value for this specific point, all of training sample. I have total 197 training sample, and I want to extract the band pixel value for every sample. So for that, extract the bands the values for all all samples. So now take a variable, suppose training, and call the image. Okay, just I call the image. So basically, if you check, this is my image. Okay, it stored this image, and from this image, I select some specific bands, and this band already stored in this variable. Just I call the variable and paste here. So now I want to extract the pixel value. So for that, use the sample regions function to extract the pixel values. So now further make a dictionary, curly bracket start, and also close the curly bracket. So first of all, collection mainly all of samples. I have total 197 samples. Just I call the samples. It's my collection, all of training sample. And properties, I already set the property name. Okay, so when I take the training sample, I set the property is the class, and I keep the training sample is the same for all of classes. Just I copy the property name and then paste here. And scale, I choose the scale 10 meter. Projection, it's not need, just I remove. It's also not need, just I remove. So now what happened? So now all of training sample extract the band pixel values, all of bands which I add in my list. Just I call the training and run the code. You check, just click on here, then we find out that features. So you can see every points extract the all of training sample, all of band pixel value. Okay, all of band pixel value. If you check, extract the all of band pixel value. Okay, so every features extract the band pixel value. Okay, and this is my data set. Okay, so I want to use this type of data set and make the classification. Okay, so we can get the property as well as also get the class 3. Class 3 is the level. Okay, and this is my property for this geometry for the specific point. Okay, so this is the data set. So this data set we need to split into train set and test set. Okay, so this data set I need to split into train set and test set. So train set we simply use train our model, and test set we simply use for check our validation. So this data set we simply split into training and testing, and we do it randomly distribution. So for that, take a variable. Suppose I put the variable name is the data set and call this training because it stored all of data set, and I want to distribute it randomly. So apply the random column to distribution this data set randomly and it's stored in this variable. So further I simply use, suppose I want to use 80% data for train set and 20% data for test set. So we simply use the 80% data for train set and 20% data for test set to check our validation. So now I want to spill the data. So how I can spill? So take a variable, suppose train set, and call the data set, and I want to filter ArcEngine.filter less than random 0.8. Okay, after that test set, so take a variable test set, so call the data set and filter ArcEngine.filter dot greater than equal random 0.8. So now we apply the greater than equal 0.8. So it take the rest of the 20% data. Further, if you check print the train set and check how many, just check it, and also print test set, then it show the how many training sample, how many training test sample. You can easily get it from here, this number. So you can see 161. So these are train set 80% data, and this is the test set 20% data. Okay, randomly choose train set and test set. So now this train set, this data set 161. So this type of sample we simply use for train our model, and this rest of the 36 training sample we simply use for check our validation or check our accuracy of our land use land cover, or check the performance level of our machine learning. Okay, anyone in question, you can ask me please. This case, any question? Okay, I hope there is no question. You can also try. Okay, so when we apply any kinds of supervised learning, before applying the supervised learning, always keep the same process. Okay, so you need to training sample, you need to merge the training sample, you need to extract the band pixel value. All of are keep the same when we apply any kinds of machine supervised learning. Okay, so now we need to create the model. So this part is very important. So we need to create the model. And Google Earth Engine, we find out the lot of model. Okay, if you check, we find out the lot of model. So it simply starts here, model, or create the, and this type of model Google Earth Engine call as a classifier. Okay, classifier. Okay, this type of model we call as a classifier in Google Earth Engine. So I simply search at classifier. So you can see there the lot of classifier is available. And you can see the different types of classifier. You can see all of this is the accent classifier, decision tree assemble. If you check, this is the support vector machine. Then also you can see the minimum distance classifier. Okay, then also cart, mainly classification and regression trees classifier. Also you can see the gradient tree boost classifier. Okay, k near neighborhood classifier. So random forest classifier. So different types of classifier we can also use in our model. Okay, so but which model is perfect for my land use land cover classification? So basically, when you work with the land use land cover mapping, there is no universal or best classifier. Okay, so we use the different and this thing also depend on the sensor data, then dimensionality, number of classes, then also complexity, landscape, availability of the training sample. Okay, and need the probability output or interpretable model. Okay, so there is no any model is perfect for this classification. We cannot say anything about that. So we can use different types of model for the different purpose, and this model selection is very important. Okay, suppose if I say about that model is rf mainly random forest, basically this model random forest, and random forest, it's widely used, okay, for this model, because this model high dimensional spectral and index data. Okay, and this advantage is that we can get the high accuracy. So when we apply the random forest, we can get the high accuracy and low hyperparameter turning requirement. Okay, so if you check this type of a model have a number of trees. So if you also use the number of trees, if also you use the low number of trees, there is no problem when we apply, because it's the low hyperparameter turning requirement and works well with the limited training sample. Suppose you have some limited training sample, not mass, suppose 20, 30 or 10, then you can easily apply the random forest and we can get the very high accuracy, and it resistance to overfitting. Okay, so it also resistant to overfitting. We also get some problem overfitting, so it also resistant to the overfitting. And feature importance inside, we can get the very good importance. And also it some weakness, suppose does not inherently model special context. Okay, and generally one of the best for land cover mapping, optical imagery. Okay, so when we apply the optical satellite imagery, suppose Landsat Sentinel to this type of optical imagery, it works very well when we apply the random forest. And it also excellent baseline classifier open when you work with the Google Earth Engine. So random forest is very popular, you can also use it, there is no problem, because we can get the high accuracy and it also resistant to overfitting and feature important insights is very good. And it also worked very well when we have some low training sample. Suppose you have only 10 sample or 20 sample, you can easily apply the random forest and get the very high accuracy. So another model, it's called the another popular model, it's called the support vector machine, okay, SVM. So this support vector machine very effective in high dimensional feature space. A high dimensional feature when you classify, you can also apply the support vector machine, and works well with limited training dataset. Also have some low dataset or limited training sample, you can also apply the support vector machine. But it also some weakness. You need the lot of parameter turning needed. Okay, but in this time, when we apply the random forest model, you need only for the one parameter. Okay, only for the one parameter, number of trees. Okay, you need only for the required the it's called the optimization, turning optimization. Okay, or hyperparameter optimization. So you need only for the one argument hyperparameter optimization. But when you work with the support vector machine, suppose this model, this one SVM, this one, you need different types of parameters. Suppose you need the kernel C or gamma. So you need all of hyperparameter optimization, kernel C and gamma. If you check, this is the gamma, this is the kernel. Okay, and also need that another one which is for C. So this type of things you need, but for the random forest, you need only for the one. You need only for the one. You need only for the one, and which is number of trees. Okay, we need to set hyperparameter optimization only for number of trees, and it's very good for the small or medium data set. You can also apply the support vector machine. And also you can see the cart. So this is another model we also use, very popular. It's called the cart. Mainly cart. If you check the cart also in here. So this model, okay, cart classification and regression trees. So this model. So this model we can apply for fast and interpretable and works in G with the minimum turning. So it also weakness. It also provides the low accuracy. So when we apply the cart model, so it lower accuracy we find out, and sensitive to noise. We also get some noisy pixel when we apply the cart, and it performance acceptable for the simple landscape. Okay, not much any high landscape when you classify it. Suppose complex classification. Suppose at the same time you want to classify forest, vegetation, trees. So complex classification, then this cart is not work very well. And it not recommended when you need the higher accuracy. Suppose you want to achieve the high accuracy up to 90% or 95%, then you just simply you don't use this classifier, because this classifier is not give you the high accuracy. So that's why it's also recommended when you need the higher accuracy, you not use this algorithm. But this algorithm advantage is that it also very fast. We can make the classification and works in Google Earth Engine with the minimal turning. Okay, you not need put any kinds of optimization about that. And finally, this is the another. It's called the K nearest neighbor. K nearest neighbor. KNN. K nearest neighbor. So this is the another important classifier or algorithm. So this weakness is sensitive to noise and high dimensional spectra degrade performance, and rarely performed for the modern land use land cover mapping. So maximum time we are use this 3 or 2. Okay, but it very rare case we use this algorithm, very rare. As well as we also use the another one, which one is the most useful. It's called the if you check, gradient boost. This one, okay, gradient boost algorithm, or you also say the GBM, gradient boost, or XG boost, or light GBM, or cat boost. So different name we can say about that. So this is very high accuracy for the tabular remote sensing feature. Okay, very and good feature for importance, and requires the careful hyper parameter turning when you work. Okay, if you check, it also have some number of trees also have. Okay, so it was very important, number of trees, to get the more better accuracy. So this type of things we can also apply in here. So first of all, I try to apply suppose random forest. Okay, so how I can create the model for random forest? So very same way, just take a variable. Suppose I put the variable name is model model and call the random forest. If you check the random forest model, this one. So just I copy all of those together. So this is my model. In this model, basically this things is not needed this time. So I just consider only one argument, number of trees. You know. Okay, so I just take only for the one. Suppose I put the one. What is the number of trees? If you simply search here and check the support vector machine or random forest, this is a support vector machine. So if you check, all of model also have the explain in here. Also you can see the so random forest. Okay. So if you check the random forest, all of those, you can see the hyperparameter turning in random forest regression, random forest classification. So just a open introduction to random forest. So if you check the random forest, when you apply the random forest, we need to create the decision tree. If you check, this is a decision tree. So in this case, it's one kind of decision tree. This is another decision tree. This is another decision tree. So there are total 3 decision tree in this case. And if you check from the decision tree, it get the result for class A. This decision tree give the result for class A, and this decision tree give the result for class B. So majority time we find out the class A. So that's why it find out output will be class A. So it's called the decision tree. So this is, it creates some decision, and based on the decision it make the class. In this case, total 3 decision tree. Suppose I create 100 decision tree or 150 decision tree. So then it create this type of 100 decision trees and find out the majority voting. Find out the majority voting and identify final class. So now I simply apply suppose one decision. Suppose I put the 150. Okay, but it's not the accurate. We simply run our model first time. I put the 150, but this thing we can also compute it. Okay, this thing we can also compute it and identify hyperparameter optimization. Okay, we can also identify hyperparameter optimization. And what is the hyperparameter optimization? Hyperparameter optimization, it achieves the high accuracy. Suppose when I put the 100, it give me the high accuracy or best accuracy. So then this 100, this number called as a hyperparameter optimization. So this thing is also related to your accuracy also. Suppose this thing also help you to achieve the more increase your accuracy, and it's called the hyperparameter tuning or hyperparameter optimization. And hyperparameter optimization help you to achieve the best accuracy. Okay, suppose we don't know which value is the more better for my model, but in this case I simply put the 150. And further next class initially we discuss about that hyperparameter tuning, more details, and how hyperparameter tuning help you to improving your accuracy of your machine learning model. Inshallah, last class we discuss about that, how to work for the hyperparameter optimization. So now I simply set a value, suppose 150, but this value is not constant. This value is not constant. First time we simply set the value and run our model, but we can also compute this value. Okay, we can also compute the value and find out the hyperparameter optimization or hyperparameter tuning. And this hyperparameter optimization or hyperparameter tuning give you the best accuracy in your model. And what is the decision tree? This is the decision tree. It's called the decision tree. Okay, in this time you can see there are the 3 trees. So now from the 3 trees it identify majority class A, so final class will be A. But when I set 150, so now it create 150 trees and identify majority voting and get the predict the land use land cover classification. So I simply put this model, okay, but this 150 is not constant. We can also change it, okay. And how I can change it? So for changing this thing, we need to learn about that hyper parameter optimization. So inshallah, I discuss about the next class about that, how we can easily get it. So now I want to train my model. So I apply the dot train function. Train. Put all of argument. So just make a curly bracket start. Just